Here is the Sounded Music Mop 11 nudge video for you. This is a good representative example of the kinds of questions you'll find in Mop 11. They ask for the wavelength and frequency of a particular wave. What they describe for you is the harmonic number and the length of the tube and the speed at which sound travels. You'll notice 335 meters per second is a little different than the 343 that I usually recommend, but you'll find different values given that are all kind of close to each other. So one of the things about this is that you're not given any information in the form of a diagram, which means you're going to have to make your own diagram. This is a very important visual part of this. So what I'm going to recommend is that you draw yourself a closed column, kind of like this, and I'm doing on here just like you would do with your pencil. So there's the closed column, and then you're going to try to draw in what that wave looks like. And it's all about the fact that it's the fifth harmonic. So remember that what we're drawing here are quarters of a wavelength. And for a closed tube, you could draw either 1/4 of a wavelength for the first harmonic, 3/4 of a wavelength for the third, 5/4 of a wavelength for the fifth, 7, 9/4, whatever the harmonic number might be. So if you do this with your pencil, it's a good idea because this isn't the easiest thing to draw if you don't do it very often. So the fifth harmonic means 5/4 of a wavelength, or another way to say that is 1 1/4 wavelengths. So what I usually do here is I will draw an entire wave, which remember is a complete crest and trough, but I'm going to leave a little bit of extra space in the tube for the other quarter. So you continue it like that. And then as we normally do for standing waves, we draw the wave at two different positions in time. So it's like trough and then crest, and then the little bit of extra for that last quarter of a wave. So what's helpful about this is if you know the length of the tube, then you can relate that to the length of the wave. So I'm going to mark here the wavelength. That's where the wavelength fits. Notice your wavelength is going to be a smaller number than the length of the tube. So what I might recommend again is, because you're mostly very visual people, if you just write what this is describing. The length of the tube here, L, is equivalent to 5/4 of a wavelength. 5/4 times lambda is the symbol for wavelength. And so what you need to do in this case is find the lambda number given the length. And that's just a little algebra. Now notice here that the length of the tube is given in centimeters, and they also ask you for the wavelength in centimeters. So that's kind of helpful. And once you have the wavelength, then you can use the wave equation to relate the speed and the wavelength and the frequency. So the wave equation says that the speed of any wave is the frequency multiplied by the wavelength. So again, what you have is an algebrated version of what you really need. You're going to be solving for the frequency. So you do a little algebra there. And I want to caution you something on this, which is the same as what you saw in a previous mop, and that is that they're going to give you the speed in meters per second, but you have the wavelength in centimeters. So I would recommend that you change one to the other. Either change the wavelength into meters or the speed into centimeters per second. That way you won't have a mismatch of units. So for this particular question, that's the process. And if you have a diagram already given, then you can just use the diagram, and they're probably not going to tell you the harmonic. You're going to have to recognize that yourself. But the wave equation part is going to be pretty common to all of your questions. So use that as a guide to get you going, and see me for any extra help that you need. Good luck.